Hello! In this video we continue gaining knowledge on SD cards. In the previous part we wrote 512 bytes of data to block 2 of the SD card, and now we want to see what our computer can see from this.
We will now use an application called HXD to display the raw binary data on the SD card. Of course, first we need to connect the SD card to our computer somehow. You can use a built-in SD card reader for laptops, but you can also buy a reader that you can connect via a USB. We will use the second option for now.
First, we disconnect our development board from the power supply. Then, we take out the SD card and put it into the card reader connected to our laptop.
Open the HXD application, click on Tools, Open Disk, then select the SD card from the physical disks list. The program will then display the stored binary data in a table form represented in hexadecimal.
You can clearly see that starting from the hexa 200 address, which is by the way 512 in decimal, exactly the start of block 2, we see numbers 0, 1, 2 and so on, exactly as we wrote on our software. However, if we open the file manager of the computer, we will not see any file. What could be the reason for this?
The fact is that computers use a file system on storage media. Just think about it. We have now written 512 bytes of data in an arbitrary location, in block 2. How will the computer know that there is data in block 2, and what does it even mean? Do these numbers represent characters? Perhaps 8-bit unsigned temperature data? Perhaps 32-bit floating point numbers? What if I want to store more than one kind of data on the medium? For example, images, music, and text.
A file system means that information, that is binary data, is placed in a specific location on the medium, in a specification that clearly describes where to find what.
There are many different file systems. Perhaps one of the best known is FAT, or File Allocation Table. It was first used in 1977. A number of variations have appeared, like the FAT12, FAT16, FAT32, but the basic principle is similar and is supported by virtually all systems. The memory space of the medium is divided into regions of equal length, called clusters, and in the first few clusters in a table, we store the cluster numbers corresponding to each file. In the FAT32 file system, a file can have a maximum size of about 4 GB, because the file size is stored in 32 bits, meaning that a file can be 2 to the power of 32 minus 1 bytes long, and the maximum size of a medium is 2 terabytes, because we can refer to 512 byte long blocks by 32-bit addressing, meaning that we can store 512 times 2 to the power of 32 bytes. The disadvantage is that if the operation of the storage medium is interrupted when the table is being written, for example if the power fails, it will contain incorrect values which will render the whole file system unusable. That way, even though we have our files on the medium, we will no longer know where to look for them.
So-called journaling file systems are designed to eliminate this problem by keeping a kind of log of what happened to the medium and when. They do this in such a way that the database describing the location of the files can be restored after any interruption in writing. A journaling file system is the NTFS, which is the closed-source file system used in Windows systems. In Linux systems, at least when this video is being released, the ext4 is the most common, also a journaling file system, which is open source.
Another more well-known file system is exFAT, which is freely available and usable since 2019, and is the default and recommended file system for SD cards and other flash-based storage devices, like pen drives. It is basically an enhanced version of FAT32.
In embedded systems, it is often necessary to store data on a flash IC soldered to some circuit. In such a case, it may also be appropriate to use some kind of file system. One implementation could be SPI FFS, which is SPI Flash File System, which can provide simple and convenient file management with very little computational power and RAM usage.
Common to all file systems is that the medium must be formatted before it can be used, at which point a database is created that is appropriate to the file system.
In the following video, we will create a simple application that will be able to read and write text and binary data to and from the SD card using the FAT file system. See you there. Bye.
Bye!